Good morning, sir. Myself Vishnu Sacharam. I am from Civil Department. So today our topic is rethinking data efficient artificial intelligence for low resource settings. So it means upgrading the global AI divided through invocation, assessment, and inclusive designs. The AI revolutions hidden divides means modern AI breakthroughs rely on massive data sets and computational power rally available outside wealthy regions. Learning AI data centers consumes as much electricity as 1 lakh households annually, creating an enormous barrier to entry. This technology gap risks creating a next great diverse in global development where low resource setting face systematic exclusion from AI-based opportunities and 1 lakh household worth annual electrical consumptions for major AI data centers also. What defines low resource settings means low resource content for face multi intersecting contrast that fundamentally reshape what effective AI means base models. So scare data means limited availability of labeled datasets of training robust AI models. Limited compute means insufficient processing power and computational infrastructure. Poor connectivity means unreliable or absent internet access in remote areas. Weak capacity means insufficient institutional frameworks to deploy and maintain AI systems. Data efficient a foundation invocation means over 300 research students reveal transformative approach that fundamental reduce AI's resources requirements. Data efficient AI is not merely a stopgap solution, it represents a foundational paradigm for equitable invocation. Few short learning means train models with minimum example 90%. It is a database also. So self-supervised learning means learn from unlabeled data. From compact to saving 75% also. And physical information models integrate knowledge and tiny machine learning deploy on edge services means it above the 50%. So case studies AI impact in low resource domains means real world applications demonstrate how data efficient AI delivers transformative benefits across critical sectors in underserved communities. Healthcare diagnostics, AI powered diagnostics tools tailored for on offline use improve rural medical care, enabling acquiring diseases detection without contact connectivity. Smart agriculture means tiny mission learning models enable real time crop monitoring on low power devices, helping farmers optimize yields with minimal resources. And climate resilience means local validated models predict weather patterns with minimal data, supporting climate adaptation in vulnerable regions. Adaptive education means learning tools functional without continuously internet access, delivering delivering personalized education to remote communities. Fine tuning fine tuning large models with limited data. So parameter efficient fine tuning techniques enables adapting large language models using scarce labeled data, making powerful AI accessible in specialized and low data environmental. These advantages unlock capabilities preserved for resource-rich organisms, demonstrating access to state-of-the-art AI technology. Domain adaptation transfer knowledge from general to specific domains efficiently. Cross-lingual transfer means leverage models across languages with minimal training data. Preserve alignment means align models with minimal human feedback for better outcomes. Outcoming energy and infrastructure barriers means Data centers powering traditional AI models strain power grids and increase environmental cost. Innovative approaches distribute workloads and reduce resource demand. Edge computing process data closer to user, reducing latency and bandwidth requirements while improving privacy and resilience. Federated learning means to train models across distributed devices without centralizing sensitive data, enhancing security and efficiency. Model compression means prune and optimize neutral works to strings AI computational and energy footprints dramatically. Ethical and institutional consideration, fairness, governance, sustainability. Fairness means avoiding bias amplification in data sets. Population requires operators informed, locally validated AI systems that understand community consistently needed. Building institutional capacity is critical to sustain AI development, deployment and maintenance, ensuring long-term viability and local ownership of technology. Sustainability means energy efficient AI aligns with the environmental goals and long-term viability, reducing carbon footprints while expanding access. Responsible AI development, resource securing, balancing invocation with ethical principles, community management and environmental stewardship. A decision matrix for practitioners and funders. Strategy frameworks to guide AI implementation based on a local context, contracts and priorities, access context, evaluate data availability, compute resource latency, tolerance and domain specific needs. Select members choose approachment data efficient technology with constraints of objectives, build commons, invest in regional compute and data commonly to demonstrate of all accesses, enable policy support research and development also, low contents through strategies funding. Key insights means sustainable AI development requires coordinated action, technology selection, infrastructure investments and policy supports. Towards equability and sustainability, AI invocation means data efficient AI unlocks transformative potential for understanding communities worldwide, making cutting edge technology assessment where it matters more. Bridge the divide. Collective action is needed to ensure AI benefits are shared globally, not concentrated in wealthy regions. Rethink AI purposes means view AI just a technology but as a tool, program resilience and human empowerment. Act now. The time for equable AI invocation is today. Join the movement to demonstrate artificial intelligence. Thank you.